Hello friends, welcome to my channel. Let's have a look at the daily challenge problem. Problem 19. Remove nth node from the end of a linked list. So in this video, we are going to share a method based on two-pointer. So here the solution is a single pass solution. First, I will read through the statement to digest the requirement, and then we do a simple analysis and give a walkthrough. Finally, we share the code. So first, let's look at the statement. So given the head of a linked list, remove the nth node from the end of the list and return its head. So here is the one example. So in this list, so we are going to delete the second node counting from the tail. So this is the first, this is second. So we're going to remove this 4 marked in red. So actually, so in order to remove this node, so we need to first locate its previous node, that is 3. So then we just need to point 3 next to the 5, in other words, to the 4 next. So this is going to be 1, 2, 3, 5. So this is example 1. So in example 2, so the list has length 1. So we're going to delete 1 node. So we're going to get an empty linked list. So in example 3, so we're going to delete node 2. So we get a linked list with length 1. So the 1 points to null. So that's these are the 3 examples. So before we look at the analysis, let's look at the constraints. So the number of nodes in the list is called size. So size is bounded above by 30. So this is actually a small size problem. So the node value is not non-negative and bounded above by 100. So this assumption is not that important. So n is greater than or equal to 1 and less than or equal to the size. So this actually is an important one. So it says that the node we are going to delete is not null. So here is a follow-up. Could you do this in one pass? Yeah, we are going to share a solution. So using just one pass. So the reason for using one pass is that so there's a naive way. So we can first traverse the linked list to get its length, and then we count the index of the node to be deleted, and then do the traversal again up to that node, and then do the repointing. So here actually one pass will be sufficient. So let's look at the idea. So before this, let's emphasize that to delete the desired node, we shall locate the previous node of that node, right? So this is actually the guiding principle. So the idea is the following. So we are going to use 2 pointers. So one is called previous and the other is called current. And we record their indices. So if their indices difference is less than n, then we move current forward, keep the previous fixed. And then we are going to increment the index of the current. So thus their indices difference is n or equals to n. Then we move previous and current simultaneously forward until the current arrives at the end. So in this case, we do not update the indices anymore. So when current arrives at the end, so the previous or the prev will point to the previous node of the node to be deleted, so which is aligned to the notice above. And then we just need to do the repointing to delete the node to be deleted. So that's the main idea. Actually, it's very straightforward. So let's look at example 1. So in order to incorporate the case in example 2, so I'm going to introduce a dummy node, so which is actually very standard. So let's assume in example 1, so the dummy node points to 1, points to 2, and up to 5. And the 4 is the nodes we're going to delete. Then we're going to set the previous to be dummy, and the previous index is 0, and the current to point to height, and the current index is 1. So currently their indices difference is 1 minus 0, that is 1. So here n is 2, right? So while the difference is less than 2, so we're going to move forward the current and increment the current index. So now the current is moved to next, that is current equals to 2. And the current index is incremented by 1 as 2. So now the current index minus the previous index equals to 2 minus 0, that is 2. So we do not update indices anymore. So we just simultaneously move previous and current forward until current arrives at the end. So for example, the first move moves previous to be 1 and current to be 3, in other words, the next of 2. And then move again, so previous moved to be 2 and current to be 4. And finally, previous to be 3 and current to be 5. So this 3 is the one we want to locate. So 3 is the previous of the node 4, right? So 4 is the one we are going to delete. Then the node to delete is previous next, that is 4. So to delete this node 4, we point previous next, in other words, we point 3 to be 5, right? We point previous next to be node to delete next. In other words, previous next is set to be previous next. So here we are using two calls of next attributes. So this is actually valid. The reason is that by the problem assumption, the node to be deleted, in other words, the previous next, is not null. So the expression previous next is valid. So this comment or this observation comes from the last constraint or last additional assumption, right? So with this example walked through, I guess writing the solution is very routine now, or straightforward. So now let's look at the code. First, let's initialize the 2 pointers. So first I'm going to make a dummy node, so which is a list node. So we instantiate it as here, the class name, and the value we can pick anyone. So let's pick -1, just for to distinguish with this one. It's not necessary at all. Then the next, so we are going to connect this dummy to head. That is the given linked list. And then what we are going to do is that, so we set previous and previous index to be dummy and 0, and the current index to be head and 1. So currently their difference is 1, right? So now we iterate. So we want to check until we arrive at the end of the linked list. In other words, while current next is not empty or not null, then what we're going to do is that we check the difference between the two indices, the previous index and current index. So if their difference is m, then what we're going to do is that we move previous and current simultaneously forward. So previous equals previous next, and current equals current next. So notice that in this situation, we do not need to update the indices anymore, because both of the indexes are incremented by 1, so their difference does not change. So in other case, so if their difference is less than m, so what we are going to do is that we increment the current index by 1, and then we are going to move the current forward only. So this way, as we are going to enlarge the gap or the indices difference towards m. So with that said, so after we arrive or we exit this while loop, so the previous will pointing to the previous of the node to be deleted. So then we just need to do the repointing, right? So previous next as previous next. So this previous next actually is the node to be deleted. Then so this is a valid node. In other words, it's not null. So if we call next, it's still a valid call. then we just repoint the previous next to be the next of the node to be deleted. And then what we're going to do is to return the dummy next. So that's a full solution format for this problem. So let's first do a special case check. Yeah, it passes the first example. Now let's do a second case check for 1, 1. So this is sort of special, right? So it's 1, 1. And then let's do this check. Yeah, it passes the second example too. So now let's do the generic case check. Yeah, it passes all the generic cases. So I guess that's about it for a solution to this specific problem. So in this video, so we used the two-pointer trick, and also we solved this problem using a single pass. And in between, so we actually used the dummy node trick just for bringing some convenience. So with that said, I guess that's it for this video. Thank you very much.